So here we go. This one will be the matrix by matrix example. So this is matrix multiplication. And it's all about organization when you do this. Okay, so a couple things to note. The inner pair here, when you line this up, so the first guy's column and the second guy's row, these have to equal. I don't know why I wrote the word two. These have to equal. And if they do equal, you can do it. And this part gives you the final answer's dimension. So this is going to be the dimension of your answer. So in this, I'm going to get a 2 by 2. So let me organize it like this. I'm going to get a 2 by 2. I'm going to kind of lay it out as 1, 2, 3, 4. There's your 2 by 2. Now I'm giving it a lot of space because I want to organize some work for you here. Okay, so to get that first element, it's going to be all about highlighting for me here. If I want, okay, we'll go blue. If I want that element, it's going to be row 1, column 1. Row 1, column 1. Row 1, column 1. So the way I do that now is I'm going to do the math. I'm going to have 8 times 3 plus negative 2 times negative 1. Now at first glance you might be going, okay, what's going on here? Well, the first guy is 8, and the first guy is 8 in the row, and the first guy in the column is 3. Pair those up. The second guy in the row pairs up with the second guy in the column, negative 2 times negative 1. Okay. Hopefully you start seeing the rhythm once I highlight again. So let's say I want to do yellow. Okay. So now this is 2. Think of this as kind of like element 2. Not 2, 1. I'm sorry. It is not 2, 1. It is 1, 2. Because it is row 1, column 2. So that row 1, column 2, the 1 piece comes from this guy, and the 2 piece is going to come from this guy. So the 1 being row 1, the 2 being column 2. But the 1 is row 1, so I'm coming here for row 1. But then it's going to be column 2. Row 1, column 2. Row 1, column 2. So now I'm going to pair up, and it's going to be, let's kind of remove this for a second. It's going to be the same original row, but paired up with the second column. So then when I do the math, it's going to be 8 times 4 plus negative 2 times 2. Okay. Now that might have been confusing, so we're going to look at the next guy. So if I look down at this guy here, this is A21, meaning row 2, column 1. Row 2 means the first piece there refers to the blue guy, and the second piece refers to the yellow guy. So if I wanted to set up some highlighting here, let's go green for this section. I need row 2 from the front, but I need to go to row 1 from the top. So it might get, let's leave the blue out for a second. I'm going to remove the blues, remove the yellows. We're just looking here. Row 2 of the first guy, column 1 of the second guy. So when I match that up, I got 5 times 3 plus 6 times negative 1. 2, 1. Row 2, column 1. The first number refers to the first matrix. So I'll even just write that. This refers to the first matrix. First matrix row. And this piece is going to refer to the second matrix column. Okay. All right, so for the last guy here, now it's a 2 and a 2, so don't get confused on which 2 goes to which 2. The first 2 refers to, I got to look at the second row of the first guy, and I'm going to be then looking at the second column of the second guy. So when I try and pair up, we got one more highlight color left here. If I was to clean up all of my work and just go, okay, 2, 2. I first need row 2 of the first guy, and then I need column 2 of the second guy. So I'm going to have it as 5 times 4. Then it's going to go plus 6 times 2. Okay? That's going to produce the number for that element. So if I slowly set up the highlights for each one, I had row 1. Okay, I'll just start again. Row 1, column 1. And I color coded that wrong, so let's try that as, let's just restart. Okay, here we go. Okay, for the first one, top left, row 1, column 1. And that reason is it's A11, meaning row 1 from the blue guy, column 1 from the yellow guy. Okay, where I'm referring to this guy as my blue guy, and I'm referring to this guy as my yellow guy. Okay, that's how you pick out element 1, 1 for the new matrix. Okay, if I want to clear the board, and I'm going to look at the top right, it's going to still be row 1, but it's going to go to column 2. Row 1, column 2, and that's all from that idea. Row 1, column 2. That means the first number is the row of the first guy, and the second number is the column of the second guy. Okay. Then, if I organize for the green element, it's going to be row 2, column 1, and that's going to produce A21. And then the last one, the purple guy, is kind of the end and the end. The last row and the last column gets you the last element. Okay, so then when you finally get your answer, you can simplify those numbers. So you're still going to have the yellow chunk, the purple chunk, the blue chunk, and the green chunk. And you're just going to do the math. 8 times 3 is 24 minus or plus 2, 24, that's 26. 15, that's 9. 28, and 32 minus 4, also 28. Okay? So that's how you can set it up. There's a lot more math involved as you're kind of distributing rows and columns, and you're trying to make sure you organize the correct row with the correct column. Now luckily, you can do this on your calculator as well. So let's set up here. I'm going to clear my work. I'll set up the matrices. Let's edit. Let's go down to D and E. So D, it's going to be a 2 by 2, 8, -2, 5, 6. And then I'll go to E. And E is going to be a 2 by 2. 3, 4, -1, 2. Okay. Now, when you do the multiplication, you are picking D, you are picking E, D times E, matrix times matrix, and it gets you, hopefully, what I had, 26, 28, 9, and 32, which is good to see that you're going, what did I do wrong? There's a lot of math. There's a lot of adding, subtracting, distributing. So I need to look at my purple guy, and I did this on purpose to check my work. 5 times 4 is 20. 6 times 2 is 12. 20 plus 12 is not 28, it's 32. So I need that to be 32, but why I'm doing that is to check my work to see how well I did. So on this, I'm going to snip this piece here, wherever it went. Let me snip this, so we can see how to check our work. All right. Okay, and I called this guy D, and I called this guy E. Okay. Curious. When you multiply, things normally are okay forward and backwards. What I mean by that is 3 times 2 equals 6. 2 times 3 equals 6. Okay, and we just discovered that if I paste this in, D times E equals that. So I'm curious, if I would have done this backwards, if I would have done the matrix E, then the matrix D, if it gives me the same. And it doesn't. This is groundbreaking for you guys, because this is the first time where the matrix, or when you multiply, order does matter. Okay, so for matrices, order matters when you multiply. Order matters when you multiply. Okay, we're going to look at another example here with this one. Okay, a 2 by 2 by a 2 by 3, and the way you check again is this has to match up. This has to equal each other. So match up. That's good. And then the outside components of this create your answer's dimensions. So this is going to be a 2 by 3. I'm going to have a piece here, a piece here, a piece here, 2 rows, 3 columns. Okay. And when you go through this, so if this was my, let's look at, this is my A11. That means, if I was trying to try a different style of coloring, A1 purple, and we'll go 1 blue. So my blue is the second guy, and my purple is the first guy. When I say A11, that means row 1 of the purple. So this is all about your row, and this is all about your column. It's the column of the blue guy and the row of the first guy. So if I was trying to highlight to do my work, it would be row 1, column 1 goes there. Okay? So let's just organize it here. This is going to be 1 times 3 plus -2 times 7. And I'm going to run out of a lot of space here, so let me stretch this all the way over. Okay. Then, if I'm looking at one like this, A row 2, column 1, A21, I would be sliding. So if I keep this here, if I was trying to do this guy, highlight real quick. If I was trying to do this guy, row 2, column 1. So it's row 2, but then it comes here to still column 1. I know that turned green, so I apologize for it. So row 2, column 1. So I'm going to be looking at 3 by 3 plus 5 by 7. Okay? Organize it that way. When you set up the next guy, this element is A row 1, column 2. So now let's just clear the board a little bit, and hopefully this helps. If I'm doing A1, 2, so A1, 2, here it is. Okay, this piece here, 1 is row 1 off of the purple. Oops. Row 1 off of the purple, but it's column 2 off of the blue. And that will help me set up 1 by 4 plus -2 by 1. Okay. hopefully you're starting to see the pairing of how that pairs up. Row 1 of purple, column 2 of blue. Okay, so why don't you hit pause on the video right now and try to solve this. Finish it out. Solve it, check on your calculator, and I'm going to set up my work on this as well. But for right now, hit pause, see what you can do, and then when you're stuck or you're ready to check, hit play again. So I'm hitting pause now, and I would like you to as well. All right, so I laid out my work. I try to organize and showcase what my numbering was. I kind of quit on the color coding, it just got messy. But my final answer after simplifying was a -11, 2, -12, 44, 17, and 30. And that's what I got with F and G. Now notice, you're not seeing this part of it, but in my calculator, I stored the purple guy. The first guy I put as F. And the second guy I stored as a 2x3 matrix G. And when you just type in F times G, it showcases my answer for me so I can see my work. Okay. I'm curious, so there's same F and G, can I do G times F? So remember, order matters when you do 2 times 3 and 3 times 2 is fine. But that's just numbers. The question is, what about matrices? And we already showed that you can't flip them and it gets the same answer. They seem to get different on that 2x2 example that I showed you. But I want to show you this, how it won't match up. If I do the G, he's a 2x3. And if I'm going to try and multiply him by the purple 2x2, I told you the outside parts would be the pairing up. This would be your final dimensions. So I'm expecting a 2x2 if the insides match. No match. So this can't happen. And if I showcase that on the calculator, you're going to see the error part. So if I do matrix G, matrix F, it goes dim mismatch because I didn't pair up again. The insides didn't match, so it does not work. Edit, paste. It fails. That's where it shows it on the calculator. Okay. Now, the next two matrices here, one of them's a 2x2 and one of them's a 3x3. So this guy's a 2x2 and this guy here is a 3x3. But the beauty of them is if you use those guys and multiplied them by a 2x2 or multiply them to a 3x3, it doesn't change your original matrix. So if I had a 1, 0, 0, 1, and I multiply, let's say, a 5, 6, 7, 8, what you're going to get, once you organize everything, you can check your things here. This is a 2x2. This is a 2x2. You can make sure that the insides match up. You know the outsides are what you pair up to be here. If you paired up and did the work. So if you first looked at there, gets you this. 1 times 5 is 5 plus no 7s, you get 5. If I was trying to pair up for this coloring, I would have there and there. 1 times 6 is 6. 0, 8 is nothing. So I'm left with 6. And if you did the rest, you would get 7 and 8. It didn't change. Same guy. Okay? And what's further nice is if you try to do it backwards and you did 5, 6, 7, 8 by 1, 0, 0, 1. When you multiply it this way, and I've told you before, order matters with matrices. Yes, they do matter, unless you're multiplying by an identity matrix. This would still get you 5, 6, 7, 8. So what I want you to think about is this. We are so used to doing stuff like 1 times 5 equals 5. 5 times 1 equals 5. So 1 is an identity in the number world. In the number world. Well, in the matrix world, if you're in a 2 by 2 world, this is your version of 1. If you multiply by 1, it doesn't change your matrix. But we don't call it multiply by 1. We're going to be calling it multiply by the identity matrix. If you're in the 3 by 3 world and you want to multiply and not change anything, you're going to multiply by that identity matrix. Now, some students think all of them should be 1s. If they're all 1s, you will change your original matrix. It will make it bigger because all of a sudden you're going to do 5 plus 7 and get 12. 6 plus 8 gets you 14. You don't want to add anything. You really just want to pluck out the same elements and correspond them to your new answer. That mumbled it. But basically, realize 1's on the diagonal, 0's everywhere else. That's your identity matrix. That's going to help us as we look through the next set of examples and why that is so important. So here's the next one. This is going to end video 2, and it's going to start video 3. So why don't you take this one here, and why don't you multiply it out? And take your time in between video 2 and video 3, multiply these out, see what you get, see how well you're doing with it, and we'll take a look at it on the next video.